Welcome to Manufacturing Tech Australia.
Naveen, welcome to Manufacturing Tech Australia, mate. Thanks for coming on the show.
Thanks, Paul. Appreciate it.
Excellent. This is very cool what you got going on here. You got humanoids running around a warehouse. At the moment, we've been playing a lot with humanoids, and we've had some demos running over in the corner, and still quite limited what humanoids can do, right? Why don't you tell me about how you're making this work in this application and how you pulled it all together?
Well, thank you guys for coming and having a look at the Daemon booth. In terms of humanoids, we're not humanoids manufacturers, but what you'll realize is that the humanoid needs a mind or an AI model or a brain to work and understand what kind of work it needs to do.
Yeah.
So at the moment, this one is a showcase with our partnership with UBTech.
Yeah.
And the model that is running is from Daemon. So we've been training a data model for the last 2.5 years, where we've got 8 or 9 different bots, and we've been training them for 8 hours a day with 3 people looking over their shoulders, telling them what to do. So a lot of the movements that you see here is being mimicked by what a person has done in VR, and is teaching the robot to be able to pick up a carton, place it onto a position, or maybe even look at a product and see if the barcode's visible or not. And then just flip it over to get the visible side of the barcode up. So it's really proof of concept in terms of what kind of menial tasks can be taken over by the bots in the future.
Cool. So using the VR to train the bots?
Exactly right.
And what does that look like? And then can they sort of learn from each other and teach each other, or is that one person need to operate each bot?
Yeah, look, we're not there yet in terms of the bots being able to learn from each other or from repetitive tasks themselves. So for every task that it fails, we have to teach it how the right methodology is to do. At the moment, we are limited in terms of that one model being run across all the platforms. So it's a shared database in that sense. Once we've got it right, it can be replicated across any other platform.
Yeah, I see. It looks like a pretty good application of this robot here with the wheels on the bottom, sort of walking around. What kind of payload can we get out of this thing?
So I'll probably give you a slight basic on that is versus the leg, the legs, humanoids, the wheel-based one is probably more suited to a warehouse setting. Because with the floor being unlevel or obstacles on the ground, this works perfectly well. It's balanced. This one does about 20 kilograms from a payload perspective. And it's got about 60 degrees of freedom in terms of different movements it's got. At the moment, it's running at 30% of its actual speed. And I guess for the showroom, what we wanted to do is to have the robot run on one charge for 8 hours in the day. So that's why we've slowed it down so the battery consumption is slightly lower, and we don't need to recharge it.
So 8 hours is still pretty good. A lot of them only running sort of 2-3 hours before recharge,
Correct, So we've only charged this overnight. It takes a 2-hour charge to fully charge, and it'll normally do 6 to 8 hours of work that we've been showing on the show.
Right. So what would this look like in terms of deployment in a warehouse? Would you do sort of a proof of concept to get started? Would you have to map out that warehouse area and sort of pre-program all the areas it has to go to? Correct.
So a lot of the modern robotics that we're seeing now is everyone's looking at SLAM as a way of learning and working. Yes, it's got onboard LiDAR. And again, we have to map the area that it works on, so the tasks are mapped and where it's taking the product is all mapped.
Okay, and I guess in future it can kind of learn a bit more dynamically, use vision to work out where it's going.
That's probably something that a lot of smarter people, smarter than me, would know. But I am told that yes, in the future we'll have a different way of teaching it, and hopefully we'll have a different methodology or a different model that runs more efficiently.
I like your thinking. Using hardware, applying the brain from you guys from all your development and testing. What other sort of applications are you looking at aside from moving stuff around the warehouse?
What we're showcasing right now is we're also showcasing a unit sorter. So think of a use case for a lot of e-com customers, 3PLs, store distribution. So we've got a machine which does 1,400 units an hour into 100 locations. Now that is still a menial task. So now we've developed a version 3 or a Gen 3 of the same bot, which can actually look at a product, find the barcode, and put that barcode in an upright position, and feed it onto that system. So imagine that bot heading into a parcel sortation facility or a mail sortation facility or a letter sortation facility where it's looking at the barcode and sorting it to the right location or handing it on to the next stage of the process.
I see. And I guess you got a bit more flexibility if it's humanoid.
Correct.
Instead of just being stuck in the one spot.
Absolutely it is,
Right. So what's to come following this? What other sort of cool things are you guys working on?
Mate, it's I honestly don't know. It's a lot of cool stuff that you see. The dancing robots out of China, the dancing dogs out of China. and obviously these bots.
Yeah.
For me, I'm not too sure. In terms of what comes from a model perspective, my hope is that we see robots that can actually do or mimic human work,
Yeah.
and take away the menial tasks and that effort into humanoid.
Yeah, the dirty, dumb, and dangerous that we're trying to get rid of, right?
Correct, exactly.
Yeah, awesome. Well, thanks so much for coming on the show.
Appreciate it. Thanks, Paul.
Cheers.
Thanks for tuning in to Manufacturing Tech Australia with Shane and Paul.